So, what is NetBird and how can we go about using it in our networks? If you've never heard of NetBird, first I'll give you a brief overview of what the product is, and then we will do a deep dive into how you can use it, the components, and the underlying technology. NetBird is an open source zero trust networking platform that allows you to create secure private networks for your organization or in your home, in which you can remote to from anywhere in the world. NetBird is designed to be simple and fast, requiring very limited configuration effort, leaving behind the hassles of opening ports, complex firewall rules, VPN gateways, tedious WireGuard configurations, and more. Setting up a remote connection is as simple as installing a peer on something like a server and then using the NetBird client to connect directly to it remotely. You can connect machines directly to each other with peer-to-peer connections, whether if they're in the same server cabinet or in completely different parts of the world. We will deep dive into this with more detail, but you can also enable routing on a peer, making it act as a connector. So then with that single peer, you can have access to other devices and services that are on that same network. This without needing to actually install NetBird on all of your devices. So first, a quick general overview of everything working together. NetBird works with a seamless integration with a variety of technologies and components. There's the management panel, which is the essential control center for everything, including the automatic WireGuard configurations, policies, peers, networks, and more. Peers connect with a control channel, helping them establish connection, and integrates with popular IDPs to authenticate users with a single sign-on and multi-factor authentication. Now, for the general setup, there are two ways we could go about doing this, and both of these methods do work with each other. The first is a full peer-to-peer mesh network. For this, NetBird is installed on every single device, enabling a mesh network, allowing direct, secure connection between all of those peers directly. Of course, you don't have to do a full mesh network. You can set it up so you actually pick what devices can communicate with what. For example, I'm running Proxmox over there on one machine in my home network with an agent running on the host. I can then install an agent off-site with Proxmox backup server, connect the two directly, just as if they're on the same network, running scheduled, secure off-site backups with encrypted WireGuard connections. Now, a key capability of peers in NetBird is their ability to act as routing peers. A routing peer serves as an entry point into a private network. This means you can designate an existing machine to be a routing peer or simply follow the installation instructions to get one set up. When a peer acts as a routing peer, it grants access from the NetBird network into the local private network. This is incredibly useful for securely connecting to internal resources such as IoT devices, subnets, and databases without needing to install that agent on every single machine within that legacy network, all while having full access and control with policies. And if you're setting this up as a business, this means giving access to hundreds, if not thousands, of devices via subnet access. Both of these methods punches through the firewall of a closed network, making controlled access to nearly anything incredibly simple. In my own case, the agent that I installed on the Proxmox server can be set up as a routing peer, and then I'll have access to all the VMs and LXCs without needing to set up a peer or agent for every single virtual machine and container. Plus, it can reach out to other devices on the network, such as my 3D printing server, my Raspberry Pi, or even the NVR. Now, you may be asking, what if a peer goes down? For example, if I only had that one peer installed on Proxmox and that server does go down, I wouldn't have access to my NVR or anything else, and that's where high availability comes in, as I can install an additional agent on the Raspberry Pi, for example, add it to the network as a routing peer, and now if either of these devices goes down and one of them remains online, I still have access to my entire internal network. So now let's deep dive into some of the individual components and see how they all work together. The first and the big one is the management service. This acts as your central control plane for your NetBird networks. That is responsible for orchestrating and managing all the peers and their connections. And this is awesome, with NetBird, you do actually have the option to self-host this first-party component if you do choose to. So now the key functions of the management service, like we discussed, there's peer registration and authentication. When a new device or peer installs the NetBird agent, it registers with the management service using the setup key. This service handles the authentication of peers, and it can handle integrating with identity providers. For network management, the management service distributes the necessary WireGuard configurations to each peer automatically, including the public keys, the allowed IP addresses, automating what would otherwise be a time-consuming and tedious manual process. All peers are given their own IP addresses with configurable DNS. This in addition to whatever their local IP addresses are, so you can choose whether to use the NetBird IPs or DNSs or your local IPs if you do set up a subnet. Overall, the management service maintains the overall state of the private network, including information about the active peers, their IP addresses, and their assigned roles. That takes us to policy enforcement. This enforces access policies you define, determining what peers can connect to each other and what resources they can access. You can define this with groups and peer groups, giving individual users and groups port-specific access. The management panel also has logging network configuration changes for audit purposes, and network activity, allowing you to identify who did what and when on your network. This includes the ability to collect and analyze network configuration changes, log all connection traffic events, and stream events to SIM platforms in real time. Speaking of SIM platforms, there's a bunch of integrations. Like we mentioned earlier, it integrates with identity providers such as Okta, Microsoft, Google, GitHub for single sign-on and multi-factor authentication. And some of these platforms allow you to manage team members and employees through it, allowing you to automatically synchronize users and groups with the correct permissions and device access through policies. And there's other integrations including EDR with CrowdStrike Falcon, SIM for event streaming, sending network activity logs through third-party platforms such as Datadog, Amazon S3, Amazon Data Firehouse, and generic HTTP. There's also mobile device management integrations with services like Camd, Jaff Pro, and Intune. And of course, full integration with Kubernetes, including Operator and more. So now the fun part, let's get into how these connections are actually established. There's two main things, and first is the signal service. This is critical for establishing direct peer-to-peer connections in NetBird, and its primary role is to facilitate the internal communication between peers and set up that WireGuard tunnel. So when peer A wants to connect to peer B, it communicates with the signal service. The signal service then informs peer B of peers A intent to connect, helping peers exchange that necessary information like network addresses to initiate a direct connection. It acts as a rendezvous point, allowing peers to discover each other even when they're behind network address translators, NATs, or firewalls. It is important to note that the signal service does not relay actual user data. Its function is purely to signal and facilitate the establishment of direct WireGuard tunnels between those peers. And then there's the relay service. This is our own implementation based on Quick Protocol and WebSocket, in which the relay service will pick the one that works best, while these relayed connections are still peer-to-peer and end-to-end encrypted. And this comes into play when direct peer-to-peer connections cannot be established. This typically happens in complex network environments where both peers are behind restrictive firewalls or multiple layers of NAT. That is preventing that direct communication, and if an automated NAT transversal fails to find a direct path, the connection will fail back using the relay server. Unlike the signal service, the relay service doesn't relay encrypted WireGuard traffic between the peers directly. This means the traffic flows from peer A to the relay service and then to peer B, but still maintaining that full WireGuard encryption. While direct peer-to-peer connections are preferred for optimal performance and security, the relay service provides a robust fallback mechanism to guarantee that peers can always communicate regardless of network complexities. So that's our overview of how NetBird works, some of the features, some of the underlying technologies, and if you're interested in learning more, our documentation is absolutely a great place to start. We have write-ups on all the features, functionality, and just about everything you could do with NetBird. So that is definitely a good place to go check out, or check out the videos on this channel. Particularly, some of the webinars do a great job of giving you a live overview of some of the key functionalities, features, and integrations. With all that, do make sure you subscribe to this channel for upcoming videos on NetBird, some use case examples, and much more. With that, I do hope you have an absolutely beautiful day, and goodbye.